All right, continuing to look at our normal distribution, we're going to look at how we can find probabilities out of it. Let me try to see if I can get this microphone a bit louder here. All right, so yeah, that's better. What we want to do is, in finding probabilities, we're going to look at how, given an actual mean, we can find the probability that some value will be less than a given value. So we're going to talk about the random variable x, and if it's normally distributed, then we can talk about the probability of a value being less than a certain value. And we do this by creating z-scores out of them. So what we can do is we can talk about what one standard deviation is, which is 100. And we can talk about the z-score being 1. And we can talk about the probability up to a z-score. So let's look at this example here. And we're going to then put this into Excel as our solution. So we have a national study found that college students with jobs worked an average of 25 hours per week. The standard deviation is 11 hours. A college student with a job is selected at random. Find the probability that the student works less than 5 hours per week. Assume the lengths of the time a college student's work are normally distributed and are represented by the variable x. So let's come over here and draw out what we have. Let me erase my board here. And we'll write down our relative information. So our mean is 25 hours. And our standard deviation is 11 hours. And we want the probability that they worked less than 5 hours per week. So we want the probability that x is less than 5 hours. So we'll draw our distribution with our mean here at 25 hours. And so we want to know the probability that it's less than x equals 5. Which, if the mean's 25, this is going to have to be to the left. Now what we can do is we can convert this to a z-score. We can say that z is equal to x minus mu over the standard deviation, or that it's 5 minus 25 divided by 11, which is negative 20 over 11. Which, if I run this into a calculator, is negative 1.82. And we can use this z-score to find the probability. But I think Excel is going to do this much better for us. If we keep track of the mean and the standard deviation, we can do a bit better here. So let's flip over to Excel. And I'm going to start a new sheet. And let's make this big enough that we can see it. And I'm going to do some labeling here. I'm going to label my mean was 25 hours. My standard deviation was 11. And I want to find the probability that x is less than 5. And so I'm going to, the variable 5 I'm going to keep over here. And I'm going to find this probability by using the normal dot distribution But I'm not going to need to calculate the z-score. It's asking me for what my variable x is, so it's going to be C7, which is the 5. Then the mean, which is C2. Then the standard deviation, which is C3. And cumulative will be true. And there we have our probability. The probability that if we randomly selected a student from this distribution of them working less than 5 hours per week would be 3%, 3.4%. So the normal distribution, by putting the x value in and the mean and the standard deviation, calculates the probability for us. So we don't have to use the z-scores, though I will continue to show the z-score examples in the book, because there will be some questions in the Pearson homework that will ask us about z-scores. And so if we look here, we get a similar calculation, that we get a z-score of 1.82, and that is 0.344. We got 0.3452. Remember, using these tables, there are some rounding issues that will come up when we do these calculations. Get back to my... So let's look at another. A survey indicates that for each trip to a supermarket, a shopper spends an average of 41 minutes with a standard deviation of 12 minutes in the store. The lengths of time spent in the store are normally distributed and are represented by the variable x. A shopper enters the store. Find the probability that the shopper will be in the store for an interval of time listed below. So between 20 and 50 minutes and more than 35 minutes. So I'm going to go right to Excel. I'm going to create a new sheet for this problem. Again, I'll make this big enough that we can see it. And so I'm going to talk about the mean and the standard deviation. And then I'm going to have my times. So I'm going to put time 1, time 2, and time 3. And so if I go back to that problem, it was asking for between 20 and 50 minutes and more than 35. So 20, 35, and 50 are the times that are in the problem. All right, let's look at this again. Oh, I'm not showing it on Excel. I'm sorry, I didn't switch to Excel. So 20, 50, and 35. So let me show you how I put this into Excel. I need to put the mean in. Which was 41 and a standard deviation of 12. So I'm just using this data here, and I'm talking about these times. So the first question asks for the probability that the time is between 20 and 50. So we'll look for that probability. And then the other probability was that it was more than 35. Those are the two probabilities the question was asking us for. So first, for the probability of being in between two things, remember we take the probability of the highest and we subtract from it the probability of the lowest. So the probability of the highest is the normal dot dist, and then in my x value for the highest is 50, or in this case I have that in F4. My mean is C2. My standard deviation is C3. Now the reason I'm using references here to cells are so that if any of our data changes, we can these values will change for us. Let's see, C3, C2. So that's my upper value. And now I need to subtract from it the probability of my lower value. So again, we're going to look at F2, because that was the lower boundary. And we'll again put in our mean as C2, our standard deviation as C3, and being cumulative will be true. And now Excel automatically subtracts the two. So if we're looking for a range, we take the higher probability minus the lower probability, and we're using the normal distribution directly with X. We don't have to go through Z-scores. Now, because all of these things are left-sided, if I want to find a greater than, I have to do 1 minus, because I'm doing the complement, the probability of our lower value, which is F3 here for the 35. And again, I give it the mean and the standard deviation, and cumulative is true. And so Excel can calculate all of these probabilities for us. And so instead of converting for Z-scores, we calculate the probabilities in Excel. And we get a, let me get over to PowerPoint here. So instead of doing these Z-scores, we get this 0.733. And if we continue on for the complement, we get the 0.6915. We got 0.69146. So there's some rounding in there, but it works out well. So Excel gives us the ability to calculate these probabilities directly off of the variables that we have. And so this lets us take our Z-score, our data, and turn it into the probability that a value exists between ranges. We did all of this stuff in Chapter 4 with discrete probabilities. The thing that works for us here is this distribution curve, this bell curve, that lets us work with continuous variables.